Alright guys, welcome to another pre-calc video. This is unit 7, last unit of the year, lesson 2. We're continuing with rational functions. Okay, we're just going to look at different forms. So right here you can see this is the general form, okay, of a rational function. And basically all that has to happen for it to be a rational function is your numerator, your denominator have to be polynomials. Okay, and we're not going to let q be 0 because that's undefined. Okay, and just we're going to go through graphing these, but now with this more general form. Okay, so remember, to have a vertical asymptote, basically what has to happen is the bottom of your formula has to equal 0, but that x value that makes the bottom 0 can't also make the top 0. So only the bottom, if there's an x value that makes only the bottom equal 0, you have a vertical asymptote. Okay, so if we look at these cases, first one, well, when x is 3, that makes the denominator 0, so we have a vertical asymptote right there, right? Plug in 3 here, you get 0. That will not happen in the numerator. In this case, we can take this denominator, we can factor it, okay, and we actually have two values. X is positive 2, x is negative 2. That will make the denominator 0. Again, if we plug those in here, 2 and negative 2, they will not make the numerator 0. So there are our vertical asymptotes. Let me turn this volume down a little bit. Okay, last one. We have 4x plus 4 in the denominator. If we factor that, we get 4 times x plus 1. Negative 1 makes the denominator 0. There is our vertical asymptote. Okay, so those are the three cases in this example where we have a vertical asymptote on the graph. Okay, the next thing. Now I'm actually going to go down here into page 2. This is the general rule for finding horizontal asymptotes, right? And remember, guys, these are not asymptotes always. I'm going to call them soft asymptotes. Okay, what they really are is an end behavior. So they tell us the limit as x goes to infinity of the function, and also that's going to be the same end behavior as x goes to negative infinity. Okay, so a lot of times they will not get crossed, but it's not a guarantee that if you have a horizontal asymptote it won't get crossed. Okay, here's the three cases. All right, and basically all you're going to look at is the degree of the top and the bottom. Okay, and again in this case we're letting p, right, represent the top, the numerator, and we're letting q represent the bottom. Case 1, the degree of the bottom is bigger. Okay, that means this is a higher degree, and so basically what's going to happen is as x gets larger and larger, the denominator gets bigger and bigger, the whole fraction goes to 0. Okay, so if you have a bigger degree on the bottom, your horizontal asymptote is y equals 0. All right, easy. Well, maybe not easy, but that's just always what happens. Okay, case 2. Case 2, the degrees are equal. Okay, what's going to happen there is you're going to take the leading coefficient of the top and the bottom and you're going to divide them. Okay, so I wrote over here, it's the ratio of the leading coefficients. Okay, an example of that is here, case D. All right, if we look, we have a second degree term here and we have a second degree term here. Okay, and so if we look at the leading coefficients of this one, sorry, we get positive 2 over negative 1. And so positive 2 divided by negative 1 is negative 2. This is going to be the horizontal asymptote of that graph. Okay? So that's the second case, right? Case 1, the bottom's larger. Case 2, they're equal. What does that leave? Well, the last case is the top is bigger, right? That is something like here, right? Letter C. We have a 4th degree term on the top. We have a 2nd degree term on the bottom. This is bigger degree, and in that case, there's no horizontal asymptote. Okay, if I go back up here, That's exactly what's happening in this graph, right? We have an x squared in the top, degree 2. We have a 4x in the bottom, it's degree 1. 2 is bigger than 1, and you guys can see, so we're not going to get into the specifics, but basically what happens is there's a slant asymptote, okay? But we're not going to go into that in this course. All you have to know, if this is your case, you have no horizontal asymptote. Okay, so now we can go through these hopefully pretty easy. Draw the horizontal asymptote on the grid. Well, I've got a degree 0 here. I've got degree 1 here. Degree at the bottom is bigger, so my horizontal asymptote is just y equals 0, right? Got it. Second case, well here they're both degree 2. 6 divided by 2 is 3. That's what we've got here. And so that, you can see here, that's our horizontal asymptote. Okay, y equals 3. Last case, this one. So we have degree 2 on the top. I already talked about this. Degree 1 on the bottom. The degree at the top is bigger, so there's no horizontal asymptote. There's actually a slant. Okay, and that's what I've written here. There's no horizontal asymptote. Okay, the last part of this first page, right, is just asking you to find the domain and the range of the function. Okay, this one we can actually do without a calculator, right? We can see that our horizontal asymptote's at 3. We can see, the vertical asymptote's at 3, right? The horizontal asymptote's at 0. And so in our domain and range, those are the only two values we have to take out. Okay, so we don't really need a calculator for that. In this next one, at the bottom of the screen right now, the thing is we have this gap, right? So we have this y equals 3 horizontal asymptote. There are a ton of y values above that, but there's a gap between here and here. So we have to find the top of this parabolic looking part of the graph with our calculator. Okay, so I'm not gonna make a video, or I'm not gonna explain how to do that. You guys should know how to do that. But that y value right there is 1.375. Okay, and so this is our range right here. This is our range right here. Y can be anything bigger than 3. Okay, in this case the horizontal asymptote does not get touched or crossed. Or y can be anything less than or equal to this y value right here. Okay, for the domain's easier. We just can take out the vertical asymptotes again. So we have one vertical asymptote at -2, one at +2. So that's our domain, right? Our domain is all real numbers except for plus or minus 2. Okay, last one. So this is the most difficult one because we sort of have two important points to find. We have to find the low point here, the low y value, and the high y value here. Okay, for the domain, we're just going to take out the vertical asymptote. That again was determined by setting this equal to 0. We got that to be x equals -1. Okay, and so the domain is all real numbers except for -1, right? We're just subtracting that horizontal asymptote, that vertical asymptote. We put this equation into the calculator, we get the point 0, 0, so that y value there is 0. That means for this part of the graph, the y values are greater than or equal to 0. We find this max. Again, using the calculator, we get the y value is -1. And so that means that here, the range of all these values is less than or equal to -1. So that's what we have. If we come over here, we have the range can be any y value bigger than or equal to 0. That's this part of the graph. Or we can have any y value less than or equal to -1. That's this part of the graph. Okay, so I'm going to stop the video there. We've already computed, or we've already discussed this, so the next video I'll come back, we'll look at example 1. We'll go through the process of how to graph a rational function. I think we'll go through this example together, and then I'll just talk through these examples. All right, so see you on the next one.